This is your Unit 8, Part B, Day 3 homework tutorial. This is the homework that deals with all word problems. And for each problem, you're going to draw the picture, label the picture, and solve the question that is being asked. If there are any decimal answers, we're asked to round them to the nearest tenth. I'm going to start on the back side of this page because if you can complete the back, then you can also complete the front. The questions are very similar. So in number 7, it says, in triangle JKM, angle M is the right angle. So let's draw this triangle. I'm going to cheat a little bit. So here's my right angle. So there's M, and then I can put J and K wherever my heart desires. It says tan of J equals 24 over 7. If you remember from SOHCAHTOA, tangent is always opposite over adjacent. So that means opposite of J is 24 and adjacent to J is 7. So let's label those sides on the triangle. So opposite of J is across, so that's 24. Adjacent is next to you, so this is 7. Since I have two sides of this right triangle, I'm going to use Pythagoras Theorem to find the missing side. Again, if a side is missing, if one side is missing, you use Pythagoras Theorem. If two sides are missing, you use trigonometry. So I'm going to take 7 squared plus 24 squared because those are the legs, and it's equal to c squared, which is your hypotenuse. 7 squared is 49. 24 squared, I believe, is 6 something. $576 equals c squared. So combine 576 with 49, you'll get 625 equals c squared, and take the square root, you get 25 equals c. So 25 is the missing side of this triangle. Now we can answer the question. It says it wants us to find cosine of k. So when I'm looking from k's first corner, you got to remember cosine is always adjacent over hypotenuse. So adjacent to k would be 24, and the hypotenuse is still 25. So it's 24 over 25. And that's it for this one. There's nothing more to it. Don't overthink it. Number 10. The height of a tower is 370 meters. From where Pete is standing on the ground, his line of sight distance to the top of the tower is 485 meters. What is the angle of elevation from Pete to the top of the tower? So you don't have to really get artsy. You can simply draw a right triangle to represent what we are talking about. But essentially, if you really want to understand what's going on, we have Pete looking up to the top of a building. And this would be the building over here. Okay? line of sight is the hypotenuse. And it says that distance is 485. So this is 485. And it says the height of the tower is 370. So that's going on this side of the triangle. It wants us to find the angle of elevation, which is this angle here. So let's call it x. So based on x, our reference angle, I have the opposite side and the hypotenuse. So that means I would use sine. So I would write sine of x is equal to opposite, 370, over hypotenuse, which is 485. And since I'm finding the angle, you got to remember to use the inverse. So that means x will equal sine inverse of 370 over 485. And now let's type it in our calculator. You got to hit second sine to get the sine inverse. 370 divided by 485. Oh, I must not be in degree mode. Nope, not at all. So let's fix that real quick. I was going to say that was one tiny angle. There we go, that's better. So it said round to the tenths place, so we're going to leave it as 49.7 degrees. Number 8, we have a 42-foot ladder that makes a 75-degree angle with the ground. How many feet up a wall will the ladder reach? So again, let's draw my triangle. And if I want to change it up a bit, let's flip it around. Just to give it some flavor. So this is my ladder. And this is my building. So the ladder forms 75 degrees with the ground. So that's this angle right here, 75. The ladder is 42 feet long. So that's the hypotenuse, or the slant. Our job is to figure out how far up the wall it will reach. So this side would be x. So based on my reference angle, which is 75, I have opposite and hypotenuse, so that means I will use sine. So sine of 75 degrees equals opposite, which is x, over hypotenuse, which is 42. Now, you're going to put sine 75 all over 1 and cross multiply. 1 times x is x equals, and then 42 times sine 75. And then we grab our calculator and type that in. About 40.6 feet. number 11. From the top of a tree, the angle of depression to a stake on the ground is 52 degrees. So let's draw this triangle. Okay. So we have our tree. So the angle of depression, you got to remember from our notes that it has to have a horizon on top. So here's your horizon for your angle of depression, which means the angle is actually right here. And it is 52 degrees. And here's our stake on the ground. That's a T for my stake, mainly to like a cross. That's irrelevant. Anywho, the top of the tree is 33 feet above ground. So this is 33 feet high tree. It says how far is the stake from the foot of the tree? So X is going to be the bottom of this triangle. Also, remember in our notes, I also mentioned that there were two angles that are congruent. This angle of depression is congruent with this angle of elevation right here. So this is also 52. So now that I know my angle of reference, based on it, 33 will be opposite and X is adjacent. So that means I'll use tangent. So tangent of 52 degrees is equal to opposite, which is 33, over adjacent, which is X. Now we put tangent of 52 over 1. Notice that X is on the bottom. So shortcut, simply switch. So you would have X equals 37 over tangent of 52. Now we grab our calculator and type this in. Alpha y equals 1. So 37 at the top over tangent 52. And you get about 28.9. And we're dealing with feet. So X is about 28.9 feet. All right, number 9 says, a ship's sonar finds that the angle of depression to a wreck on the bottom is 18.5. If the ocean floor is level and a point on the ocean floor is 95 meters below the ship, how many meters is it from that point to the ocean floor? That point on the ocean floor to the wreck. So again, draw our triangle. Then if you want to illustrate the situation, by all means, go for it. So we have a ship on top of the water. There's my water. Okay. The angle of depression. So my water line is serving as my horizon. So the angle of depression will be right here. That's 18.5. And we just got done talking about it in the previous problem that this is also 18.5. Now, it says the ocean floor is level. A point on the ocean floor directly below the ship, so directly below the ship is right here, 95 meters. So 95 is this side of our triangle. It says how many meters from that point is the wreck. So here's the wreck. That's my treasure chest, aka my wreck. So I'm looking for this horizontal distance down here. So from my angle of reference, I have the opposite side and I have the adjacent. So again, I'm going to use tangent. So tangent of 18.5 is equal to opposite, which is 95, over adjacent, which is x. And again, you notice that x is on the bottom. So simply switch and divide. So x equals 95 over tangent 18.5. About 283.9 meters. All right, our last question. Number 12, find the angle of elevation of the sun if a building 190 feet tall casts a shadow 50 feet long. So here's my triangle. So I'm looking for the angle of elevation. So that's this angle right here. So it's x for now. This is the shadow at the bottom. This is the building. And you have the sun up here in the sky, right? So it's behind the building, helping the building cast a shadow that's 50 feet long. So the shadow is 50. And the building is 190 feet. So from this angle of elevation, I have the opposite side and the adjacent side. So I'll use tangent. So tangent of x equals opposite, 190, over adjacent, which is 50. And since I'm looking for the angle, I have to use inverse. So I'm going to use inverse tan. So x equals tan inverse of 190 over 50. Now type it in. Second, tan will give us 190 divided by 50. And you get roughly 75.3 degrees. Alrighty folks, this concludes your tutorial. Again, you're going to see similar problems on the front side, so you should be able to complete those. Good luck.